Okay, so if you just saw my last video, you would have seen how the sine rule was derived, and now we're going to just start an exercise from C2 exercise to A right at the beginning, and we're going to show you basically how it's used. So, typical question. So you'll be given a triangle, okay, and what you should notice is that this triangle does not have a right angle. That is not a right angle there. So you know, just in case you weren't sure. So the sine rule is for a start. It's for triangles that don't have right angles. Before we were using Pythagoras, weren't we? When we had a right angle, which was a squared plus b squared equals c squared. But no, Pythag useless. Absolutely cannot use it for triangles without right angles. So we use the sine rule amongst other rules as okay. So that's our original triangle, and for question 1, okay, we are given the following. So we said given A is 8 centimeters, and capital A, that's 30 degrees. B is 72 degrees. Okay, so clearly not a right angle, and they want us to find B. Okay, we need to find B. That's all they've given us. So as you may notice, we've only got 2 angles and 1 side. So let's show you how the sine rule is applied. So what have we got? So we know sine A and A. I'm just going to write out the sine rule again for us. So the sine rule is this, and we want to find B, so we're just going to use this part of the sine rule. A over sine A equals B over sine B. So let's just plug these figures in and see what happens. So we've got A over sine A. Whoops. My mistake. Alright, and that equals B, which we want to find, over sine B, which is 72. Sine 72. Okay, so let's just take the sine 72 across, and you end up with 8 sine 72 over sine 30. And that's going to equal B, so I'm just going to plug that in. 8 sine 72 divided by sine 30, and I make that 15.2 degrees. 0.2 degrees, 3. I'm going to split out 3 significant figures. And so there you go. So let's have a quick review as to what the sine rule enabled us to do. So we derived this in the last video, and we didn't know the length of one side, but we were given 2 angles and 1 side. And if you notice, just change colours for us. If you notice, we had A and its opposite was, so we had that, and we had an angle, and we wanted to find that. And you'll see that sometimes, you'll get triangles where you're only given, say, 1 angle and 2 sides, and you'll use a different rule to solve that. Okay, or rearrange to see, but don't worry about that. We're just concentrating on this for now. So hopefully, just by doing the question, we've been able to see why we derive the sine rule, as well as how we derive the sine rule and how we use the sine rule to find essentially a missing side. And we'll leave it there, and we'll do more examples, and you'll see how else it's also used. So see you in the next video.